It's quite interesting because I'm coming from the Macau, of course I'm Korean, but I'm coming from the Macau and the rest of researchers colleagues are in Korea. It's kind of joint research since then. And then, by the way, one correction, which the title, this is the title, original title. This is that title in the book that is the old version. We changed the title based on this, so keep in mind. So today what I'm going to introduce is about the benchmarking of chipset about the AI. That's what we're going to do. So here's the agenda, starting with the introduction. And our chip is called Everyone Period Parallel Process. So it's simply called EOPPP. And then explain about the architecture for this one. And since this chipset is kind of new and we do have some performance evaluation. So that's what we're going to do project today. So you remember the parallel processing is yeah. So parallel processing is it's like this. It's we expect to the what we call it parallel processing everybody in order, but in the reality it's kind of messed up because of the the latencies and then the size of the queues. That kind of things and issues. So what we're gonna try to do it is that we're gonna making the idea that making those parallel in order. If that's gonna be the proper way. So due to the dependency issues, over 90% of code cannot be parallelized, must be executed sequentially. And then the memory-based intercore communication, parallel introduction executing the forward fuel. So pipeline it becomes to the boosting the clock and the speed of the parallel process. So we propose the new types of architecture of chip, which is called the EOPPP. So in that, as you can see, simply speaking, it's kind of like combination of CPU and GPU at once. So that's the idea. So we have they have advantages and disadvantages for the GPU, and then also same time about the CPU. And we kind of integrate the chipset based on this. So establishing the new parallel execution theory beyond we have some limitations. So that's what we try to break through. So one of the issues is going to be the dependencies. So EOPPP addresses data dependencies. So one of the fundamental barriers to parallelism by allowing the intercore data sharing and simulation execution through the bank memories and Azure network. So we have a CPU types in here. We have a CPU types in here, and then we use a Fibonacci sequence, and then we kind of making an order of instructions to handling the orders. So that's what we are doing, and that also make possible to making as a programmable by using the language compilers like C, C++. Onto those chip, and then we can run them to the EOPPP by adapting the casual or the conventional compilers or language architectures. So what it works is that here is architectures. So you can see that the architectures in here, and they have added networks in here. So that's we kind of it's one of the big part is that I cannot give you the details about this architecture because this is actually the FPGA design. So I cannot give you the full details. But the block diagram shows that how this architecture is working. And you can adapt again to put the typical compilers. Particularly, we originally target for the C and C++ to the top of our chipset. And then this is instructions how this is running. So intercore pipeline data structures. We have parallel UML, parallel accumulation, shift adding, and then as you see the first pages, they have those in the reality is quite a mess, but making it older. So that's how this is working by using the FIR filters also. So long story short, we do have some evaluation, but unfortunately this is not. This is still initial stages. So we don't have not yet. We don't have big progress compared to the others, but initial stages we have some improvement compared with one of the highest the CPU from the conventional one, like the Intel chipset, and then roughly speaking around 17 to 20% improvement. But we believe because this one is research is targeted to the commercial version, not just for the research. So that's the reason why in the industry, those improvement is not that enough yet. So we are still working on. But hopefully we can have some good result later on. So here is future directions. So we currently available one is 32 core, but we're going to target to the 128. And we need to still optimizing the pipeline operations to make parallel processing in order, and the expected performance improvement. Hopefully 8 times better than the current version. That's what we expect to have. So this whole project working with one of the startup company called Ormi. This is one of the Korean company making chipset. So this your right side QR code is company QR code. If you have any questions, who is CEO in this company and author of this paper gonna responding regarding your questions. That's it. Thank you very much.
Is there any questions?